All right, we're in chapter 2.5, graphs of functions. Today you're going to learn about the student will find the domain and range of a function using its graph, identify the graph of a function using the vertical line test, and describe the increasing, decreasing, and constant behavior of a graph. All right, domain and range tends to be a little tricky, but if you just go with the process, not think about it too hard, it should be fine. If you're looking at the graph of 3 halves x plus 3, domain is saying what x values can be used. So if I substituted a 4 into here, would I get a result? Yes. If I substituted 10, -7, 3 million, yes. And if you look at the graph of it, the way the arrows are, means it keeps going. So that means all your x values are being used. So logically, you could tell yourself what numbers don't work. All numbers are going to work. So whenever you see a linear equation, the domain is all real numbers. So I draw a line down, I draw a line down, and I make an R, and that means all real numbers, any number that's real. Or you can notate it from -infinity to infinity. It just depends on your preference, the textbook, or your professor. All right. So domain also, if you can't think about it logically, look at it graphically. X values are your domain. So you look on your X line and I say, okay, where do you start and where do you finish? So we start over here on this X line. Do we really start at -7? No. This arrow keeps going, breaking that barrier. Same here. We don't really start at this number. It keeps going. So if it just keeps going both ways, there's no restrictions. It's not restricted at all. It can be whatever it wants. All real numbers. Range, what numbers are going to come out? If I put any number in here, what kind of numbers are going to come out? Once again, any number. There's no restrictions. Or graphically, look at your y values. What y values come out? It looks like 7 comes out. Well, that arrow's continuing, so it's not really 7. It's going to keep going. Same down here, it's not really -6. It's going to keep going. So there are no restrictions. If there's no restrictions, it's all real numbers. Okay, let's look at the absolute value of x. So absolute value is I can put in any number and only positive numbers are coming out. So there are restrictions. Only positives come out. So our domain, though, is asking what numbers can you put in. I can put in 0, 1, 2, 3, 4, and continue. And I can put in negative numbers and numbers in between. So graphically, there's technically arrows here. That means continuing. Are there any barriers from left to right? No, those arrows mean continuing, so it's not restricted at all. So there's no restrictions. So your domain is all real numbers. I can take the absolute value of any number. Excuse me. All right, range. What comes out though? We said positive numbers. When I put in 0, I get 0. So any negatives. So you can't just really write positive numbers. It's not really sophisticated. What you would say is from 0 and beyond. So you could say your y values are equal to 0 or greater, or you can notate it, you can be 0 all the way to infinity. So that's thinking about it logically. Graphically, your barrier is here and your barrier is here. So you say I start at 0 and I keep getting an output until I hit 4, but it's not really 4 because these arrows bust through, they keep going. So you always have an output higher and higher and higher. So you start with 0 and you end with infinity. Okay, so you can think about it logically or look at it graphically. It says for the following, state whether each graph represents a function. Explain. If the graphs represent a function, state the domain and range. So I'm going to introduce you the vertical line test. I feel like we discussed this in a previous video. If we take a vertical line and it goes through our graph and it hits more than one point, then it's not a function because you're assigning it to two different outputs. Okay, so it has to be if this is X, it has to be the same Y every time. But if it's like a different Y, then it won't work, okay? So the vertical line test here, if I draw a vertical line, I have 2 points right here. Well, this is saying that I'm at 2, 9. It's also saying I'm at 2, 2, about. Well, it's assigning 2 to 2, and then 2 is being assigned to 9. It's not a function, okay? So by the vertical line test, not a function. And you could just say, when it says explain, say, does not pass the vertical line test. So nope, doesn't pass it. Here, passes it, passes it, passes it. This is a vertical line. So it's going to have many points that are on 5, negative 5, 1, negative 5, 2, negative 5, 3. So no, does not pass vertical line test. The circle, no, does not pass vertical line test. Here, oh yeah, it's curved, but yeah, it does pass. Okay, and it said, so you could say yes, passes vertical line test. Now, they asked for the domain and range. Well, there's an arrow here. We have only dealt with arrows, so the arrows continued, so it was all real numbers. So you're right, the barrier here gets broken through. It's all real numbers on this side, but if you look on this side, it doesn't continue. It starts at this number, which is 8. So you start at 8 and you work your way down. And you can keep going. I don't know where this goes, but it's saying it's going on forever. So that means every X has an output. The arrow keeps going. So I have all these X values that are going to have an output. Does 10 have an output? If I go to 10, I'm not seeing anything here or here. It doesn't have an output. So our domain is 8 and less than. Or you could notate it as I end at 8 and I go all the way to negative infinity, or negative infinity all the way to up to 8. And then your range, same thing here. Your barriers at here, these happen to be the same number. That hill could have been up higher or lower, doesn't matter. And then here you have a barrier. But the arrow's going to push through, so you don't really have a restriction down here. You just have a restriction up here. You aren't greater than 8. It just happens to be 8 as well. So you end at 8, but you can be all these negative outputs. So your range is from negative infinity and stops at 8. Or you could say your Y values are 8 and less than. Either one you could write. Doesn't matter. I don't care. Although if you see this, you need to understand it's this. Or if you see this, you need to understand it's this. Okay. When a function rises and falls, for instance this, when a function rises and falls over an interval from left to right, the function has a turning point. Okay. I shouldn't have said turning point. Okay.